Alright guys, so SRAM stands for static random access memory. Okay. Now, basically I'll explain to you first the basic functioning, uska structure kya hai, okay, and then we will understand different design issues, ye wo. So today's lecture is around an hour and a half max, not a long lecture, but please pay attention because your project depends on this. Alright. Now, first we need to understand what's the basic structure of any SRAM cell. Now, why was this designed like that? There were many versions before this, but most memory designs have all been done by empirical trial and error. ऐसा करेंगे तो होगा, so that's how it was designed. Correct. Why did Hiranandani design those buildings like that? Hafiz contractor. Why he designed it? Matlab, there is some creativity in it. Okay. So if you ask, sir, how do we know how to design our own SRAM cell? Well, you don't. Okay. Now, the basic SRAM cell structure, okay, always starts off with two latches. Starts off with a latch. Latch is something that holds the data. Basically, any latch is two inverters connected to each other. Okay. The output of one is connected to the input of another. So this is the output connected to the input. Similarly, here. Now, if I say this node is 0, what will this node become? 1, which will in turn bring this node back to 0. Yes or no? So it will, once anybody, agar ye, suppose currently I say this is VDD by 2, this is also what? VDD by 2, as a hypothetical. Correct? So both of them will start fighting each other, yes or no? ये थोड़ा ऊपर गया, ये थोड़ा ऊपर गया, तो ये इसको नीचे खींच लाएगा, yes or no? This is called as DC fighting. DC fighting. DC is what? DC voltage, na? This is called DC fighting. So, but understand that the fundamental building block of any SRAM is what? A latch. It's a memory element. It has to hold, it has to recirculate the data, na? Ek bar aa gaya to. Yes or no? Then you have your row enable or wire lines, WL. Correct? If I want to select this element, yes or no? I should have some enable from the outside, na? Yes or no? Correct? Select करने के लिए कुछ तो चाहिए ना? That only if this is 1 and this is 1 will this value here and this value here be exposed to the outside world. Correct? See, one is storing it. Correct? The other is controlling the storage. Yes or no? Anything, any data needs to be managed in a controlled way. Correct? So you have your row enables. Okay? YM or wireline, whatever you want to call it. There are different names. Correct? Now, this is basic structure. Now, this is called a 6T SRAM cell. 6 transistor SRAM cell. Basically, this point is data. This point is data bar. This point is data. That point is data bar. You can choose the other one also to be data, but you need to have a nomenclature somewhere. Correct? Yes or no? Everybody is following? Now comes how to read, write, all of that jazz. Okay. You have something called as bit line and bit line bar. These are your columns. You have bit line and bit line bar. How do they work? I'll tell you. again another latch kind of a structure. Okay, now I'll explain to you the functioning. This is what VDD, this is ground. This upar wala PMOS is called your pre-charge. Is called what? Pre-charge. First get the names clear, then I'll explain to you how it works. Okay, this is called what? Pre-charge. Pre-charge, you charge before you do something. I'll tell you how it works, but just pay full attention. Draw the diagrams later for your understanding, but pay full attention here. Now, write enable data. Write enable data bar. अगर if you are planning to write one on one side, तो automatically दूसरे side पे क्या आना चाहिए? 0. Correct? Yes or no? Now, this will be your data bar, that will be data. I'll explain to you in 2 seconds why. Left side, wherever you are storing 1, that is always data bar. I'll show you how. Hold on. Let us first understand write operation. What? Write operation. Then you will understand read. This section here, this one is called your sense amplifier. Is called your sense amplifier. Now let us, this is now the structure. Now we will understand how it works. Okay. First I want to write. Let's say I want to write a 1 here. I want to write 1. Please pay attention very carefully. I want to write where? 1. This is my target. Okay. Now, what I will do? First I will pre-charge. First I will pre-charge. So, pre-charge equal to 0. At that time, this transistor is off, this transistor is off, this is off, this is off. Matlab, what path is open? Only up till here. Correct? Yes or no? Do you agree that this node here will rise up till VDD? Yes or no? बराबर? Pre-charge on है ना? तो ये VDD तक चढ़ेगा? Yes or no? ये भी VDD तक चढ़ेगा. तो मैंने प्रीचार्ज ऑन करके छोड़ दिया. ऑन किया, I turn this transistor on, and after some time I turned it off. So this node will be dangling at VDD, yes or no? It will discharge very slowly, but it will still hang out at VDD na, for some time. Yes or no? What is? I have injected charge and then I lift it. So charge will be dangling there, na? It slowly decays. Agreed? Yes or no? Barabar? So this node will be at VDD. Immediately write enable 1. If I am writing data, so data bar will be 0. So this will be 0. This will be 1. This will be 1. ये दोनों on है. Yes or no? Parallelly, when I am doing write enable data bar data ये, I will activate the rows. This all happens in parallel. Yes or no? Understanding, following it, yes or no? First what did I do? I did pre-charge. Pre-charge करके क्या किया मैंने? दोनों नोड्स को VDD तक लेकर आ गया. फिर इसको ऑन किया. This is both in parallel. Correct? Yes or no? This is actually the same wire. This is the same wire. So this is on. This is on. Please observe very carefully. Follow the mouse. This is on. This is off. Similarly, this is on. This is on. Now, do you agree that this node will get pulled down to ground? Yes or no? NMOS passes a strong 0. Barabar. The minute this fellow starts falling, this guy is already at VDD. Yahan will be VDD minus V threshold. Yes or no? Correct? Yes or no? NMOS will never pass a strong 1. Will always pass a strong 0. ठीक है, कोई टेंशन नहीं ना. This guy is falling. So this guy once falling to 0 will already, this guy will start rising. Plus this guy is already at a higher potential. Yes or no? तो दोनों एक दूसरे को पकड़ के, this will become 1, this will become 0. Following? Yes or no? Correct? So this is a write operation. Similarly, now you realize why I put data bar here. Now suppose you want to write a 0. Suppose I want to write a 0. तो इन दोनों को on करो. इस ये automatically off है. So what will happen? This node will get pulled down to 0. This one will go up to 1. But before any write operation, पहले क्या करना पड़ता है? Pre-charge. Before any write or read operation. Now first what did I discuss? Write. Write में क्या है? First pre-charge equal to 0. Correct. Then in parallel, WL write enable data. Correct? Yes or no? Mansi, correct me if I... Okay? Understood? Yes or no? Okay? Now, अभी suppose मैंने यहाँ पे 1 write किया, यहाँ पे 0 write किया. बराबर? Obviously, can both ever be 1? No. Both can never be 1. It's not electrically possible. Okay? Now, let us understand the read operation. Now let us say, first, as usual, what do we do? Pre-charge. This node will come up to VDD. This node will come up to VDD. Okay? Just inject. No guesses for why ऊपर PMOS है, बराबर? बराबर ना? Because PMOS will always give you strong ये. Now, if I have VDD here, now what I do is WL equal to 1, WL equal to 1, write enable equal to 0, write enable equal to 0. Data से कुछ लेना देना है? नहीं है. The minute write enable is minute write enable is 0. Now what happens is, observe carefully. This node is at 1. This node is at VDD. Okay. This node is at 0. Correct. Now what will happen to this node here? अभी क्या ये दुकान बंद है ना? ये दुकान भी बंद है. Correct. This node here will start going to ground, yes or no? Thanks through this path. Correct. Similarly, this once this fellow starts going to 0, this guy will automatically start rising. मतलब ये पॉइंट में और ये पॉइंट में थोड़ा भी अगर फर्क आया, थोड़ा भी गिरने का फर्क, तो SRAM will switch, yes or no? ये SRAM switch करेगा ना? What is originally you look there, you don't look at my face, you look there. What is residing here? 0. I turn this on. This is off. So this node is seeing what? This 0, yes or no? Correct? Correct, yes or no? Similarly, are you following, yes or no? Similarly, this node is seeing what? 1, which is already VDD यहाँ पे. ये VDD 1 आएगा इधर भी तो भी VDD minus V threshold ही होएगा ना. But at the end of the day, there is VDD sitting here. So both of these will flip, yes or no? मतलब this will become 1, this will become 0. This is the output of your for your read operation, na? Correct? Understood? Yes or no? Yes. Now, sometimes you also put one more transistor here, यहाँ पे, which is your read enable as well. Which is your read enable. Now, if you put this here, no, it's okay, no problem. Even if you put this here, you put read enable, and when read enable is 1, here also read enable is 1. At that time, you are controlling, you are isolating the sense amplifier from the top section and the bottom section. यहाँ पे क्या आएगा? VDD minus V threshold. But still, it is greater than 0, ना? बराबर? So, in some SRAM designs, you might have a read enable on top as well, so that you can isolate. मतलब रीड एनेबल भी थोड़े टाइम के लिए दिया और खींच लिया. मतलब जो SRAM के पास जो इनपुट है, दैट इज अ गुड इनपुट. अंडरस्टूड? यस और नो? नाउ क्या? That's what I'm saying. At that time, you can say, you can even give read enable as 1 at that time. Yeah, simultaneously. I'm saying, but for some designs, did I include it in this design? No. Okay. You can even call this, sorry, this is not called read enable, my mistake. It's called sense enable. It's called sense enable. Okay, it's not called read enable, it is called sense enable. But you can decide to put it as sense enable or not. In our design we are not using it. Okay, but I'm just telling you कि ऐसा है, ताकि तुम लोग और कोई बुक देखेगा तो बोलना नीचे सर ने गलत सिखाया. Understood? Yes or no? You are using sense enable? Okay, the law has spoken. There is sense enable. So you're using 3 transistors. Okay. So there is sense enable as well. Okay. But you all understand, right? You need sense enable as well. Clear? Yes or no? Now wait. This is one cell and sense amplifier. This is what? One cell and sense amplifier. Your SRAM has precharge, then cell 1, cell 2. When I say cell, it includes your bit line, transistors also. Full 60. Are you following? Yes or no? You have, correct? ठीक है? Now, finally, नीचे you have your sense amplifier, then your ground. Now, ये sense amplifier का जो output है, that is then passed on to a flip flop. You need some memory element to latch the output, na? Correct? Yes or no? So, typically with every SRAM you have something called as an SRAM controller also. ये प्रीचार्ज 1 करना, फिर इसको 1 करना, ये 1 करना, सबका एक टाइमिंग रहता है ना. Yes or no? Who handles that? That is handled by your SRAM controller. So a lethal SRAM chip design project is not only the SRAM memory part with the decoder. I'll explain to you why you need decoder and your sense amplifier, but also you have your memory controller. वो मतलब थोड़ा must design होएगा. If you want to do a very cool BE project, then you do your SRAM with your SRAM controller. मतलब that will be a lethal BE project. Okay, because कहाँ ना कहाँ तो controller signal देना पड़ेगा ना. Yes or no? You can't put the head, you can't put it on your microcontroller's head कि भाई नहीं पहले प्रीचार्ज भी तू दे, ये भी तू दे, ये भी तू दे, तो बोलेगा मैं ही बनाता हूँ ना सब कुछ. So SRAM के अंदर there is a clock and there is a controller. Basically controller क्या करता है? प्रीचार्ज देगा, फिर your sense enable देगा, write enable देगा, data enable देगा, फिर फ्लिप फ्लॉप को कब enable देना है ताकि ये जो डेटा आएगा फ्लिप फ्लॉप के आउटपुट पे भी आना चाहिए. All of this is handled by the controller. Understood? Yes or no? Now in your project you are doing an 8x8 SRAM memory. 8 bytes. 8 कर रहे हैं ना? हाँ, 8 bytes. 1 byte is what? 8 bits. So you will have 8 such columns. So column 0, 1, 2 up till 7. So totally you will have what? 8 sense amplifiers. Yes or no? Everybody is following me? Correct? Yes or no? 8 sense amplifiers with 8 outputs. Understood? Yes or no? Now let me ask you a question. Who takes care of enabling these rows? You take the decoders. You all are making a decoder ना, वो 3:8. Basically मेरे 3:8 decoder को मैं क्या देगा? 3 bit का address. Correct? Yes or no? Three bit address, and similarly one of these will go like this. It goes through and through. Yes or no? Barabar? It goes through and through. Are you guys following? Yes or no? Now, why am I saying there are few design issues here? Design issue number 1. Do you agree that this precharge fellow has to charge this line like this, 8 others? Yes or no? Plus your sense, either sense enable wala ye transistor. Correct? Yes or no? Following? तो इसका sizing comes into play. Yes or no? इसको size करना पड़ेगा ना. In your design 8x8 में इतना problem नहीं है, but when you are doing 64x8, then precharge sizing comes into play. In your circuit you don't have to size, but I'm telling you where the sizing issues are. Following, yes or no? क्योंकि देख how big this transistor is. Look here, how big this transistor is will govern how fast these nodes will go up to VDD, yes or no? जब तक सब nodes VDD पे नहीं चढ़ेगा, can you confidently say कि ये node VDD पे है? नहीं ना? Understood? Inversely, you have to size these guys also, so that they can pull it down to ground faster. So what are the sizing constraints? Precharge and your pull down circuitry as well. Write enable, sense enable, all of that. Understood? Yes or no? Wait. Second design issue. ये जो तुम्हारा डिकोडर का आउटपुट है, ये जो डिकोडर का आउटपुट है, in each cell that guy is going to see two NMOS gates, yes or no? ये गेट एंड ये गेट, करेक्ट, yes or no? दो NMOS गेट देखेगा, बराबर. So one decoder for an 8x8 architecture will see 16 NMOS gates, correct, yes or no? So you have to take the sizing of the decoder also into account, बराबर ना. डिकोडर का लोड क्या है? 16 NMOS ना. एक one line of your decoder is seeing 16 NMOSs, correct? Second line will also see 16 NMOSs. All these 8 lines will see 16 NMOSs each. तो उसका sizing also comes into play ना, बराबर. ये तो ठीक है, 8x8 is simple, but if you are doing a, now I'm going to explain another architecture. Sizing of your NMOS, sizing of your decoder is very important. I'll explain to you. Wait, 16 NMOS समझ में आया? हाँ या ना? So what is the second sizing constraint? Decoder size है. First is your bit line. This is called bit line. This is bit line bar. So taking care of your lines, उसका sizing. पहला वो sizing issue है. Second sizing constraint क्या है? Decoder. Now, do you agree that suppose instead of 8x8 it is now 64x8? Possible ना? 64 bytes का memory, correct? मतलब प्रीचार्ज सर्किटरी बड़ा करना पड़ेगा, yes or no? 128 64 KB 64,000 locations, मतलब सोच प्रीचार्ज सर्किटरी कितना बड़ा रहेगा. Do you agree that we should do it only like one local train? No, now you understand the logic, right? What we are doing for 8x8 is quite straightforward. But if you are doing 64K, 64,000 locations, your pre-charge guy has to charge how many guys? 64,000. Yes or no? Are you following? You understand the issue? So what is the alternative? Now instead of doing 8x8, let us split this into two parts, 4x8 and 4x8. Previously we had how many? 8 columns. So सो रहा है, देख इधर. तो सोने का आदत है क्या? FPGA क्लास में भी सोता था. 4x8 and 4x8. Now there are total how many columns? 16. 16 columns na? 8 here and 8 here. Correct, yes or no? So now the individual load on your precharge is how many cells? 4. Yes or no? नहीं समझा. इधर 8 था ना, अभी मैंने 4x8 कर दिया है. Now instead of 1 2 3 4 5 6 7 8, it is 1 2 3 4, 8 such columns. Another 1 2 3 4, 8 such columns. Correct, yes or no? So the load on your precharge circuitry reduces. But hold on, I have to now choose between these two na. So now I will need a column decoder. बराबर ना? बराबर. So basically what, now my row decoder, how many locations are here? 4. So I need a 2:4 decoder. Now what I will do is, I have 3 bits of address. अभी भी location कितना है? 8 location है. Location कम नहीं हुआ. Location कितना है? 8 है. What I will do, bit 0, bit 1 and bit 2. MSB I will use for controlling column decoding. Understood? Yes or no? The MSB I will use for column decoding. Obviously, na, first locations will be stored here. First 4 locations will be stored here. Location 0, 1, 2, 3. 4, 5, 6, 7 will be stored here. So if I say, I'm saying location, I'm saying access location 0, 0, 1. So 0, 1 मतलब कौन सा? Second location. Of which bank? Bank 0. This is bank 1. You understand? Yes or no? Bank is what? 0. Correct? Yes or no? Now let's say it's location 101. क्या बोलेगा? ठीक है 01. मैं क्या करेगा? इसके सब दोनों को एनेबल करूंगा. बराबर? इधर से भी डेटा आएगा, इधर से भी डेटा आएगा. But because this fellow is 1, I will select this one. Understood? Yes or no? Correct? Pakka? Everybody understood this? 100%. No, you don't split the PMOS. You don't split the PMOS. सुन, ये ऐसा सर्किटरी है ना, ये प्रीचार्ज अभी भी कितना रहेगा? 16 प्रीचार्ज रहेगा अभी. पहले कितना था? 16. अभी 32 प्रीचार्जेस हो गया है. हर एक कॉलम में कितना प्रीचार्ज सर्किटरी है? 2. बराबर. तो करंटली 8/8 में कितना था? 16. अब इधर भी कितना है? इधर भी कितना? 16 प्रीचार्ज यहां पे है, 16 यहां पे है. खाली मैंने नंबर ऑफ रोज कम कर दिया है, तो प्रीचार्ज सर्किटरी छोटा बनेगा. Yes. Yes, you're right. So now that's a trade-off. You have to understand how much do I split. It's a trade-off. Oh, it matters a lot. That's what exactly. अरे बॉस, अगर वैसा होता था तो सब ऐसे एक लंबा लाइन में कनेक्ट कर देता था ना. You're saying hypothetically. Exactly तेरा हाफ होता है क्या अगर तू साइज बढ़ाता है तो? तेरा डिले एग्जैक्टली हाफ होता है अगर तूने साइज डबल कर दिया? नहीं ना. डेटा ऑब्जर्व किया कभी? Did you ever observe the numbers? If you double the size, does your delay exactly reduce by half? नहीं ना. तो क्या assumption पे तूने बोला it's the same? You're saying that I have reduced it by half. Correct. But you also see if I split it into 2, I get my data faster also, no? What I'm saying is, you're saying it should be the same. Why don't you test it and tell me it's coming out to be the same? I'm telling you it's not going to come out to be the same. Well, in the world of VLSI design, when you're running your clock at 1 nanosecond clock, 1 gigahertz का जो rate पे अगर 1 nanosecond पे लगा रहा है, तो slight is also very important, right? Suppose if I'm able to save 10 picoseconds, that is 1% improvement. You do understand that, right? In the world of small, slight is big. समझ रहा ना? In the world of small, slight is very big. Try करके देखना, मैं तो इतना ही बोल रहा हूँ. When we used to do this, when we did the SRAM design at USC, we were asked to test different architectures for the same design, whichever is faster. VLSI design is always about trade-off. ये बढ़ाएगा तो ये कम होएगा, ये कम होएगा तो ये बढ़ाएगा. You have to find the sweet spot. You are right. I'm not disagreeing with your question. Correct. Which is better? You have to try. अगर सब सेट होता था तो VLSI डिजाइनर को इतना पैसा क्यों मिलता था? सिंपल ना. Coders are not paid. Programmers are paid. Coding is easy. Programming is difficult. You understand that? So that's why IT इंडस्ट्री, मैं बोल रहा ना, TCS does not pay people 3.5 lakhs because you deserve 3.5 lakhs, because that's the market norm. You actually ask a TCS VP how much you deserve, बोले 1 लाख के ऊपर मैं नहीं देगा. हाँ, it's a fact. Understand this, just putting it out there. Okay, but anyways, see, the answer to your question is you need to now wait, let me finish. अभी प्रॉब्लम क्या है, ये डिकोडर छोटा हो गया, yes or no, 2:4 बराबर. हाँ नहीं, लेकिन इसका अभी प्रॉब्लम क्या है, बिफोर दैट गाय वाज सीइंग how many NMOS, 16 NMOSes, now he'll be looking at 32 NMOSes. 16 इधर का, 16 उधर का, तो इसका साइजिंग बढ़ेगा. 2:4 है बट अ बिगर साइज. अंडरस्टूड? करेक्ट? Yes or no? Now wait, I'm not yet done. This, suppose let's say location 0 of here and location 0 of here, sorry, row number 0 and row number 0, उसका एक बिट लाइन और बिट लाइन बार आएगा. yes or no? Do you think कि यहां सेंसैम्प लगाना चाहिए, यहां सेंसैम्प लगाना चाहिए? सेंसैम्प तो होगा ना, yes or no? हर एक कॉलम के एंड में नीचे सेंसैम्प होता है. या फिर, so I'm saying I'm using different colors for different regions. So this is bit line 0, bit line 0 bar, bit line 0, bit line 0 bar, but this is bank 0, this is bank 1. Question is, should I put 2 sensamps here or using column enable short it and then give it to sensamp? पॉसिबल है ना? yes or no? मतलब दोनों बैंक का कंबाइंड एक नीचे सेंसैम्प, मैं डिसाइड कर रहा हूं कहां से डेटा आना चाहिए. करेक्ट? yes or no? दोनों लाइन में से एक का ही आउटपुट लेने का ना. सो आई कैन ईदर सिलेक्ट दिस फेलो और दिस फेलो. दिस इज थैंक्स टू माई this output. yes or no? Correct? Option is, if you want high speed, then you put your bit line bars, then you give them, each of them, an individual sense amplifier. Okay? और if you, because see, ये डालने से पहले थोड़ा टाइम लगेगा ना जब तक ये इधर आएगा. yes or no? अगर यहां पे डाला है तो ऑलरेडी दोनों अपना आउटपुट लेके तैयार रहेंगे. yes? Answer you choose. Everybody understood what I just did? Yes or no? Yes or no? See, either I can select one of the 2 bit line or bit line bars and then give it to sense amplifier, which is correct. Yes or no? Finally, अगर ये off है, suppose ये वाला off है, ये वाला on है. Correct? Yes or no? इधर एक inverter भी लगेगा. Correct? This will come like this and it will come here. Correct? Yes or no? So if this is 1, this will be 0, this will be 1. So now this transistor is off. Now only this fellow will come here. Yes or no? तो जो भी है, whether इधर 0 है 1 है, तो depending on what your read operation or write operation is, sorry, depending on whether you are reading 0 here or you are reading 1 here. Understood? Yes or no? समझ में आया? क्लियर? या फिर दूसरा ऑप्शन क्या है, हर एक को अपना खुद का सेंस एम्प दो, फिर आगे चलकर बिटवीन द आउटपुट्स ऑफ द 2 सेंस एम्पलीफायर्स देन यू डू सिलेक्शन. बट एट दैट टाइम यहां पे यू विल नीड अ ट्रांसमिशन गेट. ट्रांसमिशन गेट मालूम है? मैं समझाता हूं क्या है. See, why? Because ये sensamp का output can be either 0 or 1. The minute it's 1, means I need a PMOS to pass it, yes or no? Correct? The minute it's 0, I need an NMOS to pass it, yes or no? So I need this kind of a gate. This is called as a transmission gate. When you have a PMOS and an NMOS like this, where their source and drains are shorted, okay, then you need to pass it through a, मतलब then this is called as a transmission gate. अगर यहाँ 0 आया तो आउटपुट 0 आएगा, thanks to the NMOS, और अगर इन यहाँ 1 है तो आउटपुट 1 आएगा थैंक्स टू द PMOS. Everybody following? Yes or no? Any questions? Obviously यार, ज़्यादा सेंस एम्प लगाएगा तो ज़्यादा एरिया आएगा ना. हाँ, ट्रेड ऑफ बॉस, हाउ यू डिज़ाइन इट. स्पीड नेसेसरीली बढ़ेगा नहीं बोल सकते ना, तेरे प्रीचार्ज के साइजिंग पे भी आएगा. फिर तेरा डिकोडर का साइजिंग क्या है, क्योंकि उसका इंपैक्ट तेरे डिकोडर के साइज पे भी आएगा ना. हाँ, लेकिन तेरा डिकोडर का साइजिंग बढ़ाना पड़ेगा. नहीं, कितना बढ़ेगा वो, दैट इज द होल एस्पेक्ट, राइट. दैट इज व्हाई डिजाइनर्स आर पेड सो मच. देयर इज नो वन फिक्स्ड वे ऑफ गेटिंग इट टू वर्क. करेक्ट. See, your row decoder complexity might reduce, but now your column decoder complexity just went up ना. अभी 4 कॉलम लगा दिया, मतलब 4 बैंक में उसको शिफ्ट कर दिया. करेक्ट. लेट्स से 64 क्रॉस 8 को यू डिड 8 क्रॉस 8, सॉरी 16 क्रॉस 8, 16 क्रॉस 8 वैसा. सो नाउ कॉलम डिकोडिंग भी करना पड़ेगा ना. दैट इज डिजाइन बॉस. If I could say just by looking at it, I would have gotten $1 million per hour for consulting. I can save a company at least close to 6 months of design cycle time. Boss, that is the whole point, right? You understand the amount of trade-offs here we are talking about, yes or no? That is why designers are paid the big bucks. The first say which is better, sir, try करके देखना पड़ेगा schematic में. You all can try later, मतलब you can try later. ठीक है. 8 क्रॉस 8 इज अ वेरी सिंपल डिजाइन. 8 क्रॉस 8 में साइजिंग इश्यूज नहीं आता है, सब मिनिमम साइज से चल जाएगा. करेक्ट. बट इफ आई गिव यू ऑल लेट्स से 64K मेमोरी और 128 लोकेशन, 128 क्रॉस 8, 128 बाइट्स का, तुम लोग को 1 महीना तो सिर्फ साइजिंग में ही जाएगा. Because y'all are still getting into the world of sizing, na? But why am I discussing all these issues? So that in the future, if you ever give an interview based on memory design, you should be able to say, sir, इधर प्रीचार्ज का साइजिंग इशू है, पुल डाउन सर्किटरी का साइजिंग इशू है, डिकोडर का साइजिंग इशू है, रो डिकोडर का, कॉलम डिकोडर का, अगर मैं स्प्लिट करेगा तो क्या होएगा. ये बंदा पक्का इंटरव्यू में पूछेगा ये. व्हाट इफ आई स्प्लिट दिस अक्रॉस टू, व्हाट विल हैपन. तुम लोग का फिर चालू हो जाना चाहिए. देखो सर, द नंबर ऑफ ये row enables, the number of NMOSs you see is more, so your decoder sizing, the decoder complexity will reduce but the sizing will increase. Then you will have a column decoder as well. Understood? Yes or no? समझ में आया? नहीं है, मतलब SRAM is an interesting concept. Correct? Yes or no? Clear? Yes or no? How do we write? First pre-charge. Correct? Wait for that node to come up. Then depending on whatever data, sense enable 1 वो तो करना ही पड़ेगा. Correct? नहीं तो वो उसको बाहर जाने ही नहीं देगा. Correct? Yes or no? Then comes your write enable. Read enable है ही नहीं. That is sense enable. Data bar. If you want to write a 1, you understand that structure. Accordingly, one person will get pulled down. Obviously your rows have to be activated as well. वो रो कहाँ से एक्टिवेट होगा? रो डिकोडर से. So you have to take the decoder delay also into account. समझ में आ रहा है ना क्यों मैं बोल रहा हूं? ये जो है, this is coming from your row decoder, correct? So decoder है, correct? Yes. So when this fellow has to go 1, and this fellow, all three of them have to go 1 together, yes or no? So you have to give address such that you have to take this decoder delay into account. ये सब तुम्हारा कंट्रोलर का सिरदर्द है. The controller has to know, बॉस इसका इतना डिले है, तब मैं जाके उतने ही डिले बाद. So suppose इसका डिले है 5 नैनोसेकेंड्स. कितना है? 5 नैनोसेकेंड्स. तो at time t equal to 0 मैंने एड्रेस दिया. So at time t equal to 5 nanoseconds, I will give this one and I will give this one, so that all three of them will go 1 simultaneously. Understood? Yes or no? Yes, सब design है boss. This is, you're not expected to take, well, yeah, this part you will have to take into account because you will be writing the test bench for the, मतलब you will be the memory controller. You will be acting as the memory controller. You don't have to design a memory controller, you have to act like the memory controller. मतलब पहले प्रीचार्ज को 0 करो, करेक्ट, फिर एड्रेस देने का, फिर कब राइट एनेबल ये सब करने का, वो सब तुम लोग को देखना है. अंडरस्टूड? यस और नो? है अभी, है तो है, कुछ कर नहीं सकता. मतलब डोंट लुक सो स्कैर्ड. वंस यू अंडरस्टैंड इट देन यू विल फिगर इट आउट. बट ये समझ में आया? यस और नो? सो राइट ऑपरेशन, क्या डाउट है? नहीं बोलना, क्या हो गया? ओके, नहीं, इफ देयर इज अ डाउट प्लीज आस्क. प्लीज. सो फर्स्ट व्हाट वी डू, प्रीचार्ज, then write enable data wire lines together, then one will flip in one direction, other will flip in the opposite direction. Read operation क्या है? Precharge. Always first comes precharge, then wire line and sense enable. बस wire line and sense enable, correct. Automatically जो 1 है 0 है वो उसको खींच लेगा. Sense amplifier output. The output of your design that you will be checking is your sense amplifier output. However, in actual design, this output goes to a flip-flop. Correct? Hold on. Flip-flop का एक clock भी है, correct? Yes or no? और एक data enable भी आता है. क्या आता है? Data enable. So memory controller should also know कि जब ये 1 हो रहा है, when this data is 1, when this data will go 1, then only at that time I will make data enable 1. This could be 0 also. At that time also data enable should go high. Understood? इसलिए मेमोरी का अलग से मेमोरी कंट्रोलर भी आता है. Normally it's a BE project that people make on an FPGA, which is an SRAM memory controller. That is also one more, because you have to take the SRAM data sheet. So, but in your project you will not be using a flip-flop. However, Mansi will record a lecture on how to make a flip-flop and all of that, just for your information कि flip-flop कैसे बनाना है. In your project, you are not expected to do the flip-flop. Okay? Now, let us understand flip-flop. SRAM समझ में आया? Yes or no? There are two structures. You can divide it along different, you can make it different banks also. Correct? Yes or no? Banks का advantage क्या है? Precharge, individual precharge circuitry का size कम होएगा, लेकिन decoder का size बढ़ेगा. Column decoder भी will come into action. Understood? Okay. Now let us understand the basic structure of a flip-flop. Now the flip-flop that you all have learned using those master slave SR latches वो नहीं है. This we will do using transistors and inverters. Okay? And transmission gates. The structure is as follows. This is the transmission gate. Okay, D and Q होता है ना flip flop का. Now I'll explain to you how this works. First, do you all know what is positive edge triggered and negative edge triggered? When it's positive edge triggered, मतलब positive edge पे input will go to output. D flip flop क्या? Delay flip flop, मतलब input is same as output. T flip flop is toggle flip flop. Now, let's say your data is 0. First, पॉजिटिव एज डिस्कस कर रहा हूं, नेगेटिव के लिए जिधर क्लॉक है उधर क्लॉक बार कर दो, जिधर क्लॉक बार है उसको क्लॉक करो, सिंपल. But follow this very carefully, what I'm about to explain. First, when clock is equal to 0, मतलब ये दुकान चालू है, yes or no? मतलब ये डेटा इधर आया, इधर आके क्या बैठेगा 1. ओके, ओके, hold on, sorry, I made a small, one second, wait. बराबर, correct, हाँ, this is right. Now when clock becomes, one second, wait, I made a small mistake, I'm sorry, it should be opposite. Sorry about that. This will be clock, bar, okay. Now when clock is 0, this is 0, hence this is on. Clock bar is 1, means this is also on, so this goes through here and this is 1. Okay, now when your edge arrives matlab clock will go from 0 to 1, so this will get on, yes or no? So this 1 will then transfer here as 0. Now when this clock switches, when clock is 1, at that time you want this fellow to hold the old output, yes or no? You want him to hold the old output. This is your master latch, this is your slave latch, so you want this latch to hold the output, yes or no? When clock is equal to 1, so clock bar, correct. Now when clock goes back to 0, at that time you want this fellow to hold the output. See, when clock is 1, this fellow is on, this fellow is on, so whatever this data 1 was here, वो अपने आप भी जाएगा और रीसर्कुलेट होके भी एनफोर्स होएगा ना, करेक्ट, yes or no? It will go through like this also, and it will what? Recirculate from here and go like this. Correct, yes or no? Starting में 0 था data, clock is equal to 0, so at that time in red this is on, this data will come here as 0, will invert, will become 1, correct, because this line is on. So as long as this line is on, this data will always be at 1. Now the minute clock flips, so this becomes on, this fellow is shut. I have to make sure that this one goes through, and not only goes through, is maintained, yes or no? So I will make sure this one becomes on, yes or no? Correct? Yes or no? So this will flip through and go here, yes. Now वापस क्लॉक क्या 0 हुआ, मतलब ये बंद हो गया, but still this fellow should maintain his output, yes or no? So this will be, this is a positive edge triggered, मतलब this one works on clock equal to 0, this one will work on clock equal to 1. अगर नेगेटिव एज करने का तो सबको बस इन्वर्ट कर दो, जिधर क्लॉक बार उधर क्लॉक, जिधर क्लॉक उधर क्लॉक बार. ट्रस्ट मी, इट विल वर्क. अंडरस्टूड, यस और नो? क्लियर? दिस इज योर बेसिक फ्लिप फ्लॉप. अभी इसमें हाँ, नो, ऑन द पॉजिटिव एज, सी इट्स अ 2-step प्रोसेस. एट एज इज इक्वल टू 0, पहले तो दुकान उसको अंदर लाना पड़ेगा ना, यस और नो? देन व्हेन इट फ्लिप्स 1, it crosses the border. बाहर से it will look like a positive edge triggered, but actually it's made up of 2 level sensitive latches. It is made up of 2 level sensitive latches. One latch is sensitive to the negative level low, and the other edge is positive level. Sorry, the other latch is positive level. Together they form a edge triggered. Yeah. Correct? Understood, yes or no? नाउ द क्वेश्चन इज, इसमें एक डेटा एनेबल डालने का है. क्या डालने का है? डेटा एनेबल डालना पड़ेगा ना, यस और नो? नहीं तो क्या है, एवरी एज ऑफ द क्लॉक इनपुट इज आउटपुट, इनपुट इज आउटपुट. वैसे थोड़ी ना फ्लिप फ्लॉप काम करता है. यू नीड अ डेटा एनेबल, यस और नो? ओनली व्हेन आई टेल यू दैट टाइम यू शुड लोड द डेटा. बराबर ना? तो कैसा करेंगे? एनी क्या? हाँ, मतलब ट्रांसमिशन गेट के पहले और एक ट्रांसमिशन गेट. ट्रांसमिशन गेट के पहले, बिफोर द ट्रांसमिशन गेट, यू पुट वन मोर. ट्रांसमिशन गेट के पहले यू पुट वन मोर. Understood? Yes or no? Basically, only when this is on, basically you say data enable bar, data enable. See, at the end of the day, if this is off, आगे जो भी होने दे, clock आके जाने दो, कुछ फर्क नहीं पड़ता है. This fellow will be holding his old data. Correct? Because this one will be circulating old data, na? Yes or no? That's it. This is your flip flop. Now, in this, there is set and reset also. I'm just giving you a hint. Set and reset is by putting NAND gates either in the forward paths. So, NAND gate अगर डाला मैंने यहाँ पे, if input is, any input is 1, output is, अगर ये 1 है तो 0. So, NAND is typically used for set, I think so, because when you put here and if anytime this is 0, whatever is here, this is always 1. So you have to work out that circuitry. I'm just telling you, giving you a hint. If you want to do set and reset, you have to put NAND and NOR gates in the path. Okay? Alright? But again, basic functionality of flip-flop समझ में आया? हाँ या ना? Correct? So now, let's stop this lecture and record it.